Today's lesson is on parabolas. This is a little abbreviated from what the other two classes learned on Monday, but I think you can do this part on your own, and then we'll expand upon it when I get back to class on Thursday. So what you know previously is that graphing a linear equation that will give you a line, but now we're switching to quadratic equations, which will give you a parabola. Now, the first time we graph this most basic quadratic equation, I want to use a table, and then after that we will be done with tables. So let's see what we get for y if we plug in these different values of x. So first let's plug in -2 for x, and plug in -2, -2 squared is positive 4. Then we can plug in -1 and get 1, plug in 0 and get 0, plug in 1 and get 1, and then plug in 2 and get 4. So you can kind of see that some of the numbers repeat a little bit. So now we're going to take these and graph them as ordered pairs. So first we're going to plot point -2, 4, -1, 1, 0, 0, so forth and so on. Okay, so if we plot these 5 points, it'll look something like that. And so if we connect the dots, this gives us our most basic parabola. And the thing to remember about parabolas is they're more U-shaped than V-shaped, so you don't want to make the line straight, you want to make them curve a little bit. Okay? Now that we have it graphed, let's identify some of the important aspects of our graph. This point right here is called the vertex of the graph. That point is important because it's where the graph changes direction. So that vertex point is the point 0, 0. This line right here is the axis of symmetry, and the axis of symmetry is the line where you could take the graph and fold it in half, and it would match exactly on both sides. Now, this axis of symmetry is drawn as a dashed line because it's not actually part of the graph, but we do need to identify it because it's really important. This is a vertical line, and we graph a vertical line. It's always x equals a number, and it's right there on the origin, so it's going to be x equals 0. Obviously, this graph opens up. Now, the domain is going to be the set of all of our x values. And when we look at domain, we're going to do a vertical line test, and we're going to run left to right. Now, imagine you're running a vertical line going left to right across this graph. Even though you can't see all the points on this particular graph, the graph is getting wider and wider and wider. So no matter where I run my vertical line is going to touch this graph at some point. Maybe way up in the sky, but it's going to touch it at some point. So since the domain is going to hit it anytime I run my line left and right, I would say the domain is all real numbers, and I write it like this: -infinity to infinity. Anytime I'm writing it, this is in set notation, I put parentheses when I have infinity or when I'm reaching up to that number but not including it. Now let's talk about range. Range is the set of y values, and you're going to do a horizontal line test, and you're going to go from bottom to top. So pretend you're taking your pencil, a horizontal line, and running it from the bottom all the way to the top. So imagine this, because you can't really see me pointing my pencil, but you're dragging it up, it's not touching, and then it finally starts touching at y equals 0. So our range starts at 0. And since it's actually on that point and touching it, we're going to put a bracket instead of parentheses, and then it goes off into the oblivion and continues to touch it, so it goes to infinity. Alright, let's see if we can do it. Now this function right here is called our parent function, and everything is based off that parent function. So now that we know this, okay, let's see if we can graph some of these other ones. As we're looking at it, whatever is added or subtracted is going to control the x of our vertex, and this number out here is going to control the y. Well, there's nothing added subtracted to the x, so our x is 0, our y is going to be 2. So we're going to start by graphing that vertex. So we're going to graph the point 0, 2. And if you remember, our last vertex started at the origin. This one is now shifted up 2 points. So by adding the 2, it's taking that exact same graph and simply shifting it up. So let's see if we can figure out where the points are without plugging them in. Well, every time we square, we're going to start by going over one space left and right, because we know it's symmetrical, so it's going to be the same in both directions, whether I go left or right. But when I go over one space, 1 squared is 1. So when I go over one space to the right, I'm going to go up 1, and when I go one space to the left, I'm going to go up 1. Now, this time I want to go over 2 spaces. Well, 2 squared is 4, so I'm going to go 2 to the right and up 4, and 2 to the left and up 4. I'm not going to plot it, but if I went over 3 spaces, 3 squared is 9, so I'd start at the vertex and go over 3 and up 9, and we'd keep going. You can keep going for a very long time, but it's going to grow pretty quickly. So then I'm going to draw in my graph. Now we're always going to have that same pattern. We're going to start at the vertex and have that same pattern. This is my axis of symmetry. Okay. This is still on the axis, so this is x equals 0. My graph still opens up. The domain, remember that is our x, and we do the vertical line test. So pretend your pencil is a vertical line running up and down. Drag it across, even though it doesn't on the actual graph on the paper, because this gets wider and wider, it will hit in every spot. So the domain, the x values go from infinity to infinity. The range, now this is the y, and this is a horizontal line test, and I'm going to start at the bottom, always start at the bottom and go up. Nothing, 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 and finally starts touching once it gets to 2. And it touches the point 2 exactly, so I'm going to put that bracket on it. And so it's going to go from 2 all the way to infinity, because once it starts, it's never going to stop. Okay, let's look at number 2. Again, whatever is added or subtracted figures out the x's, and then this is the y. So their vertex is going to be 0, -3. So I'm going to start at 0, -3. This one is shifted down 3 units from our original parent function. Okay, same pattern to find other points. If I take 1 and square it, 1 squared is 1. So starting at the vertex, I'm going to go right 1 and up 1, left 1 and up 1. Then now I want to go over 2. So if I went over 2, 2 squared is 4. So I have to go up 4 on both sides. Make the points. Here is my vertex, or my axis of symmetry, which is still x equals 0. Yes, some of these things are going to change in a minute. This one opens up. My domain, that's my vertical line test. I'm going to run it from left to right, and it's always going to hit a point. So this goes from -infinity to infinity. My range, start at the bottom with a horizontal line and work up. Nothing, 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 but it starts at -3. So my range is going to go from -3 to infinity. Okay. Now let's see what happens if there's something with x. Remember, this is controlling the x, and this is controlling the y. So the y, there's nothing added or subtracted on, so it's 0. And here's the catch. When it's in the parentheses, it's the opposite. So since it says -1, we really want +1. So now I'm going to graph that point, 1, 0, which would be right here. So from the original parent function that we started with in the first example, this is shifted 1 to the right, which is kind of the opposite of what you think would happen. Okay, let's use our pattern. We go over 1, we go up 1. If we go over 2, we go up 4. Here is our graph. Our axis of symmetry runs right through here. Well, now our axis of symmetry, it's still vertical, so it's still x equals, but it no longer goes through 0. We're figuring out where it hits the x-axis, which is right here at 1. So the line is x equals 1. This still opens up. Our domain is the vertical line test. It's still going to be all real numbers from -infinity to infinity. But the range, I start at the bottom, up, 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 nothing until I get to, and I'm looking at where it hits at the y. And where it hits at the y is at 0. So it starts at 0 and goes to infinity. Okay, number 4. This is controlling our x, and this is our y. Now remember, the opposite of what's with the x, our vertex is -3, 0. Okay, let's graph this. It still opens up, it's all open now. -3, 0 is here, our pattern. Over 1, up 1, over 2, up 4. This is our line. Here is our axis of symmetry. It's still x equals, but this time it's x equals what? Where does it cross the x-axis? And that is at -3. The domain, -infinity to infinity. The range, nothing, nothing, nothing. It starts right at 0. So I'll bracket. That's going to be 0 to infinity. Alright, so now we've got something in both. So this is going to control our x, and this is our y. So our y is the same, which is going to be the positive 4. But the x, remember, is the opposite of what's in the parentheses, so it's going to be positive 2. So we're going to start at the point 2, 4. But it doesn't matter where our vertex starts, we're still going to have the same pattern. Over and up, over 2 and up 4. And here's our parabola. Here's our axis of symmetry. This time it crosses at 2, so it's x equals 2. It opens up. Our domain on all of these today are the same. The range, nothing, nothing, nothing. It starts at 4. You go over to the y-axis here at 4. So it's going to be, oops, with a negative 4. It's going to be from 4 to infinity. Okay, I want you to try this one on your own. Pause your video and then check to see if you get the right answer. Okay, here's the answer for number 6. Did you get the right thing? Remember, for the vertex, it's the opposite of what's in the parentheses, but the same for what's with y. Alright. And if you look, you weren't sure, if you look at the range, it's starting at negative 3. That's why I did this here. Alright. Now all of a sudden we got something different. We got this negative in front of it. Okay? And the negative is not going to change anything except the direction. So now, instead of opening up, it is now going to open down. Okay? This is still going to be the x, this is still going to be the y. So our vertex is going to be 0, 0 on this one. Now we used to go over 1 and up 1, but now we're going to go over 1 and down 1, and over 2 and down 4. So here's the parabola. Here's the axis of symmetry. So the axis of symmetry is now on the axis, so that's y equals 0. It opens down. Now the domain, still as you do that vertical line test left to right, it's still going to be from negative infinity to infinity. However, the range, remember you start at the bottom. Oh, it's touching, touching, touching. It stops at 1. So it stops at 1, but it's all the negative numbers, which would be all the way to negative infinity, right? Oops, it's not going to extra parentheses for no good reason. So that is your range. So it's the opposite of what it's been, which makes sense because our graph is the opposite. Okay, so this is your x, this is your y. So there's nothing with the x, and this negative sign does nothing to the vertex. You ignore it when you're staring at the vertex. So it's going to be 0, 4. So we start at 0, 4, but because this negative, it's going to go down. So we're going to go right 1, down 1, right 2, down 4. Here's our parabola. Here's our axis of symmetry, which is going to be x equals 0. It opens down. The domain on everything is the same today. The range, though, going from the bottom up, touching, 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 stops at 4. It stops at 4, but it goes all, it starts at negative infinity and works its way up. Okay, number 9, we got stuck with both of them. So this is your x, and this is your y. So remember, when it's in parentheses, it's the opposite. So this is negative 2 and positive 1. So we're starting here, but we're going down. So we're over 1, down 1, over 2, down 4. Here's our graph. Here's our axis of symmetry, which is going to be x equals, what is across the x-axis? At negative 2. It opens down. The domain is all real numbers, negative infinity to infinity. The range, touching, 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 stops at 1. So it's all starts at negative infinity and stops at 1. That's it. We are all done. Okay, so you have your homework now from the sub. You can try it, and then next class on Thursday we'll expand on this and review it, and we'll be good to go.